Hello everyone, and welcome back to the Mathlete Academy. Today we'll be going over Chapter 15 of your math textbooks, titled Factorising, and we'll be learning how to factorize and simplify certain different mathematical equations. Sometimes you'll need to factorize some equations like these. As you can see, we have ax plus ay plus 2x plus 2y. Now here, what you want to do is you want to try and find the common factors in order to simplify them down. So for here, we have a common factor of a, so we'll take this out. We'll have ax plus y plus 2x plus y. And what we can do here is, now that we have two sets of x plus y, we can make this one factor, and a plus 2 will be the other factor. So a plus 2 times x plus y is our simplified equation, as you can see here. This is how we simplify some of these certain equations. Let's just take a practice example like this, for example. So we have 3ax minus a plus 12x minus 4. And what we're trying to do here is we're trying to simplify this down into two factors that, when multiplied together, will give this result. So what we need to try and do is need to try and get two sets of the same value. So a plus b xy, and then this will become a plus b times x plus y, because these share a common factor. And what you can do is then take the a and b out, because obviously if we have an equation like this, we multiply the a by both these values and the b by both these values, so it's just the same thing. So a plus y b xy, and this is how we can factorize. It's basically doing an expansion in reverse. So here we obviously have a set containing a. We can take the a out, well, we're left with 3x minus 1, because obviously no coefficient means there's just 1, so it would be minus 1. This is our coefficient right here, plus, and then we can take 3 out of this little equation right here, so we got 3, sorry, not 3 out of this equation, we can take 4 out of this equation, so we have plus 4 times 3x minus 1, because this divided by 4 gives us 3x minus 1. And as you can see here, we have two of the same factor, so we can use this in order to just simplify down to a plus 4 times x minus 1, 3x minus 1. And this is how you'll know if you're doing it correctly. You'll have the same grouping with just like a different factor that it's multiplied by, and then these two will become this factor right here, and these two, obviously you've got this common factor, so it's just one of the two factors in this simplification. We can try on two more of these just to make sure you've got the idea. So 3ab plus 6a plus 5b plus 10. Obviously I can see two certain groups here, so we'll use the 3ab plus 6a, and we can take out the a from this, so it just becomes a multiplied by 3b plus 6. And then over here we can take out the 5b plus 10, so we can actually just take out, let's just take out the 5, so this becomes 5 times b plus 2. And over here you'll see that these don't share the same common factor, so what we can do is we can simplify this one a bit further. We can take the 3 out as well, so this becomes 3a times b plus 2, because we've just divided this by 3, right? And then we have b, 5 times b plus 2. So in the end, we've simplified this down to 3a plus 5 times b plus 2. And this is our simplification right here. Now let's try with this one over here. We have 12x minus 8xy minus 15 plus 10y. And what you want to do here is, obviously we saw with this last equation that we did have to make an extra step. So what we want to try and do is we want to try and take out the highest common factor possible. So here, between these first two values, I can see that the highest common factor that we can take out is 4x, because this will leave this without going into expressing them as rational numbers and just keeping them as whole numbers. So this will leave this as 3, and this will leave this as 2y. So this just becomes 4x times 3 minus 2y. Then over here, what we can do is we can actually take the negative factor, because we've obviously got a minus 15 right here. So what we can do is take negative 5 out of this, because negative 5, divide this by negative 5, negative 15 divided by negative 5 becomes positive 3, and 10y divided by negative 5 becomes minus 2y. And look, this is the same factor shared between these two. So we can actually do minus 5 times this, because this individual segment will give us back minus 15 plus 10y, as you can see. So our simplification right here is now 4x minus 5 times 3 minus 2y. I hope you understood that. But what happens when we have a quadratic, an equation like this? Let's just say x squared plus 3x plus 2. What would we do in this instance? Obviously, we're trying to factor out the x's, but we're trying to make it into a form which has factors x plus a times x plus b. Now a plus minus b, right? And so in this form, you may be wondering, how do we factorize this equation? And at first, it looks kind of complicated, but what you can do is you can learn a method. So first, look at this number specifically, and also the coefficient of x. Here, it's just going to be 1, because it's very simple. We're just going to have 1. Now, what you need to do is you need to multiply the coefficient of the x squared value multiplied by your value here, your ending value, the one that has no, x to the power of 0 or whatever. But it has no x value. You multiply these together. So our answer here is 2. Obviously, this is just this number right here. Obviously, when we have other, numbers here in this coefficient, like 4, for example, it would be 4 multiplied by 2, and you get 8. But here it's just 1, because there's no value for the x. And you also take this middle value right here. So I'm just going to label this in red, 3. Now, what you do here is you have to go through the factors of 2, right? Because basically what this a and b value means is that the a and b's add together to get, when a and plus b, you get your 3 value right in the middle, because this middle value is the signification of, let's just show you what I mean. So when we expand this equation in this form, we get x squared plus a plus b x. So a plus b x plus ab. If we go by your your traditional expanding the brackets, where you have expand like this, you multiply this by this, and then you multiply this by this, you end up with this equation. And now look at what these values correspond to. This a plus b corresponds to the 3 in this equation, and this a times b corresponds to the 2 in this equation. Obviously, and this gets different when we factor in a change in the coefficient, but for now, when we just have the x squared value, this is what each of these means. So what we need to do is we need to try and find a number, two numbers, a and b, that add to get 3, and that when multiplied we get 2. So what we do here is we list off the factors of positive 2. We've got 1, 2, and we also can't forget about our negatives, negative 1 and negative 2. Obviously, in this circumstance, only one of these will add to positive 3, which will be 1 and 2. So this means we can split this middle bit right here into 1 and 2. So 1x and 2x is 2. Now we can do our factorization method that we've shown up here. So what we do is we take this first bit and we take the second bit and we take a factor out of both. So we'll take x out of this first bit to end up with x plus 1. Then we'll take 2 out of the second bit to also end up with x plus 1. Now we have x plus 1 as a common factor. So what we could do, this just becomes, take the x plus 2, and this just becomes x plus 2 times x plus 1. And this is our solution to this factorization. But obviously, what happens in this circumstance when we have a coefficient in front of the value? All we need to do here is we need to multiply this value, this coefficient value, by our ending value that we were discussing earlier. So it's 12 times 5, we get 60. And so basically now what we're looking for is we're looking for numbers that multiply to get to 60 and that add to get to 32. So and these are both positive in this circumstance. So we're looking for numbers that multiply. That's next, sorry. And then we're looking for numbers that add. So now what we do is we just list off the factors of 60 until we find two numbers that add to get 32, right? So factors of 60, we've got 1 and 60, 2 and 30, and look, we've already found it, 2 and 30. When these add together, you get 32. So now all we have to do is we just have to split this middle term into 30x plus 2x, and I'll just do it up here. Plus 2x plus 5. Now, as we said before, we'll take a common factor out of this part of the equation and a common factor out of this part, just using our method as before. So here we can take out 6x. 6x can take out, just becomes 2x plus 5. And then out of here, we can just take 1, it seems, because we've got 2x plus 5. And look, now we have two sets of 2x plus 5, and we've got 6x plus 1. So our factorization here is just 6x plus 1 times 2x plus 5. I hope I've explained this in the best way possible. I'll do a few more. Let's do this one at the end right here. So we have 8 times 21. So I believe that's 168. I'll just check that on my calculator real quick. Yeah, it's 168. Okay. So now we're looking for factors of 168 that when added together will give us 34. You can ignore negatives in this equation because you have two positive signs right here. So that means it has to be only two positives, because the thing is, when you have two negative roots, so two negative a and negative b, that means this sign in the middle will always be a negative and this sign will be a positive. But when you have negative a and positive b, or positive a and negative b, this sign can be positive or negative, and this side, because they're not being multiplied together, a negative doesn't cancel out with a positive, this will always be negative. So the only way for these two signs to both be positive is if both of our roots that we're trying to find are positive. So a and b both have to be positive. Obviously, I'm just talking about a and b in our solution, right? So both of these numbers that we split the middle term into have to be positive. So 168, we got 168 to, this might take me some time, 284, 442, 6, so we're looking for 34, I believe 6 is a factor. Let me just pull out my calculator, just to have a look. They probably won't give you questions like this. So 6 and 28, and oh look, 6 plus 28 gives us 34. So now we split the middle term into 6 plus 28 plus 28 plus 21. Now remember, we just take the first and second bits, find a common factor, and we group them. So we'll take out 2x to get 4x plus 3. And then out of here, we can take 7. 7 to get, to get 4x plus 3. Now this is shared, so we can just simplify this down. So it just becomes 2x plus 7 in brackets times 4x plus 3. This is our factorization of this equation. Alright. Now, what do we do in order to simplify something like this, where we're dividing by a certain value? What we can do here is we can just find factorizations to help make our lives a bit easier. So what we can do here is we have our factors n minus n on the bottom. And what we can do on top, we can factor out m squared to get m minus n on top. But see how these signs are inversed? What we can do here is we can just we can just take out the negative from this term on top, because if we take out a negative, that means that this, the n value, is going to become positive, and your m value is going to become negative, because now we'll just say negative m multiplied by n minus n, because remember, when we put the negative m squared back into here, this term will become negative because it's multiplying by a negative. This term will become positive because two negatives cancel out. So we take out the negative, take out negative m squared, and look, we have m minus n on the top and m minus n on the bottom. So these just cancel out, and our final solution is just negative m squared. Alright, so you may be wondering, that was just a simpler equation of what we're going to do here. So when we have more complicated divisions like this, where you're dividing by a whole fraction, it's always easiest to just simplify it down. Obviously here they've flipped it, because remember, when you're dividing by a fraction, like 6 over 5, when you can flip it, so it becomes times 5 over 6, you flip these, and you've also changed the multiplication sign from a divisor to multiplier, which is much easier to deal with, and this is still like the same value, right? These are still equivalent, so it's always easier just to flip it and change it to a multiplication. So obviously they've done that here, and then they've just taken the factors, and what you can do here is, look, you can see the factors that we have on the top, on the bottom. So x minus 3 we can take out x minus 1. So what we end up with is, look at right here, this is what we end up with. X plus 3 times x plus 1 on top over 2x minus 1 squared. Now let's just try this for our own on an equation like this. So what we can do here is we can just simplify these two quadratics and this one as well. So we'll just start with 16x squared plus 8x plus 1. So we're looking for numbers that multiply to give us 16, because 16 times 16, and that add to get 8. So 16 has factors 1, 16, 2, 8. 4 and 4, and look, this is our solution right here. So it's 6, and now we just split it, so 16x squared plus 4x plus 4x plus 1. Here we take out 4x, and here we just take out 1. And see, look what we've got here. We've got 4x plus 1 times 4x plus 1. 4x plus 1 squared on top. Now let's look at this bottom one right here. We'll just put it on the bottom right here for now. So we're looking for 8 times 3 is 24. So we're looking for factors of 24 that add to get 14. 24, we got 1, 24, 2, 12, and look, 2 and 12 add together to get 14. Now we'll expand. So we have 8x squared plus 12x plus 2x plus 3. We can take 4x out of this first bit, so it becomes 4x times 2x plus 3, and we can just take 1 out of this second bit. So now we have a shared factor of 2x plus 3. That means here, this just simplifies all the way back down to 4x plus 1. We'll keep this separate, 4x plus 1 times 2x plus 3. Now over here, looking at this fraction right here, we already got 4x plus 1 on the top, so we're just going to leave it. And now we'll look at the bottom one right here. So it's when we're multiplying these two terms together, make sure you always include the minus sign, because this term right here is minus 3. So it's 4 times minus 3 is minus 12. So we're looking for numbers that add to get plus 4 and multiply to get minus 12. As I was discussing earlier, if this sign is negative and this sign is positive, that means one of our terms is going to be positive and one of them is going to be negative, because if you have a negative fraction, it just multiplies. It'll always be a negative, right? Because it doesn't have another negative to cancel out. So we'll do one negative. So we got 1, negative 12, negative 1, 12. So we're just looking for a plus 4. Then we've got 2, negative 6, negative 6, 2. And oh, look, we've already found one right here. Oh, wait, sorry, not... Wait, I did the wrong thing. Sorry. It's meant to be negative 2, 6. And this is our correct solution right here, because 6 minus 2 is positive 4. And, yeah. So, now, what we're going to do is we're just going to split this middle term. 4x squared plus 6x minus 2x minus 3. Now we take the front term right here and we just take out 2x. So this just becomes 2x plus 3. And then we can take out minus, so minus 1 from the second bit. So it becomes, so we just, basically what we do is we're just taking out minus 1 from the negative 2x and minus 3. So this just becomes positive 2x plus 3, right? And so now what we end up with is 2x minus 1, plus 1, minus 1 multiplied by 2x plus 3. And now that we have all our factorizations, what we can do is we can just rewrite this equation. So obviously it's a divisor, so we can just flip this fraction. So what we end up with is, this might take me a little while to write out, 4x plus 1 squared over 4x plus 1 times 2x plus 3 multiplied by, and we're just going to flip this, so we'll have 4x plus 1 our denominator, and then we'll have 2x minus 1 over 2x plus 3 as our numerator. Okay, now what we can do is we can just simplify. So obviously 4x plus 1 divided by itself, we can just get rid of the square here. And now look at this. We don't have to rewrite this as a singular fraction. Obviously, when we're multiplying, we multiply the denominators together and we multiply the numerators together. So what this means is we can just cancel across fractions, because this is going to be in the denominator, it's going to come under here, and this is going to be in the numerator. So we can just cancel these out, and same for this one. It's going to be in the numerator, it's going to be in the denominator over here. So we can also just cancel these ones out. And we can do this across fractions as long as there's a multiplication sign in the middle, right? And so what we're left with at the end of this is our final solution, which is going to be 2x minus 1. This is our simplification of this equation, right? Alright, and just a quick note, I just want to show you about what I was talking about before about the negative signs, like flipping these values. So if we have something like this, we have something like this where it's 2x, 2 over negative 1x. And how can we prove this? So let's just go to the negative 2 over x minus 1. So what this means is that we can just, if we take do what we do to the denominator as what we do to the numerator, you can, like, if you multiply the numerator by the same thing as the denominator, it'll still equal the same fraction. So if we multiply the top by 6 and multiply the denominator by 6, obviously they'd still both cancel out in the end, and we'd be left with the same fraction, right? So what we're going to do is we're going to multiply both the numerator and the denominator by minus 1. So we end up with 2 minus 1 times x minus 1. And see, what this minus 1 does is it flips the x to being negative, and it flips the minus 1 to being positive. So what we end up with is just 2 over negative x plus 1, which can be rewritten as 1 minus x, which is equal to this equation, right? So just something to keep in mind. Now, when it comes to adding fractions, what we need to do is we need to multiply our denominators so that they have so that they're under the same lowest. They have a common denominator, right? And so that we can bring it together as one fraction. And what this means we'll have to do is we have to multiply our numerators by like a certain value, right? Obviously, I don't think I explained that very well, but like basically what I'm meaning is that when we want to add or add or subtract fractions, we have to make sure that they have the same denominator first. So something like this, or 1/6 minus 1/12, we can try and find the lowest common denominator, which if we multiply the 1/6, both the numerator and the denominator by 2, we get 2 over 12. And now we can easily simplify this, just being 1/12. So what we're doing here is we're simplifying these denominators into these factors, right? So we've got x minus 2 times x plus 4, and then over here x minus 4 times x plus 4 times x minus 3. So the x minus 4 is already shared, so we don't need to do anything with it. So we'll just multiply this side by the x minus 3, multiply this side by the x minus 2, and bring them together, right? Because whenever you do the bottom, you have to do the top, and we have to bring the x minus 3 over to this denominator, and we have to bring the x minus 2 over to this denominator to make them both the same denominator. So we have to do the same to the numerator, right? So we end up with x minus 3 minus 3 times x minus 2, and then from here we just simplify, right, until we end up with our final fraction. So I'm just going to walk you through a few of these. So we can try this one up here. So we have 3 time over 2x minus 1 minus 1x plus 2. Okay, so now what we need to do is these don't really share a common factor, so we're just going to multiply the numerator and the denominator by x plus 2 on this side. We're going to multiply the numerator and denominator by 2x minus 1 on that side. So we just end up with, obviously under the same, we have a common denominator now, so we can just simplify this to 2x minus 1 over x plus 2. And we have 3 times x plus 2 minus 1, which is just the same thing, so it just becomes minus 1 times 2x minus 1. So remember when we have the minus, we carry them to both sides, so this just becomes, we have to make sure we carry it to both of these, so this just becomes, if we just expand this out, it just becomes 3x plus 6, if we've expanded, minus 2x plus 1, because two negatives cancel out and make a positive. So then we can just further simplify this down to 5x plus, not 5x, sorry, just x plus 7 over 2x minus 1 x plus 2. Right? And this is our final solution. So let's just try another one. We can try this one with the k's over here. So what we'll do is we can just simplify this expression right here into factors, because as you can see, it's kind of a bit more complicated. So we can just break this one up into factors. So we have k plus k minus 20. So obviously no coefficient here, so we're just looking for values, and this is just 1. So we're looking for values that multiply to get minus 20 and that add to get plus 1. Okay, so we just list off the factors of minus 20, 1 minus 20, 2 minus 10, 4 minus 5, 5 minus 4, and look, we have a match right here. So 5 minus 4 is equal to 1. So we can split this middle term to plus 5 minus 4k minus 20. Now we just simplify. We can take k out of this first one to end up with k plus 5. Then we can take minus 4 out of the second one to end up with, obviously it just becomes positive, because if we multiply the negatives back in, it becomes negative 4k and negative 20. So we just end up with our two factors of k minus 4k plus 5. Alright? And now what this means is that you can see that these factors are already, some of these factors are shared by these two fractions. So this already has our lowest common denominator, because what we do is we multiply the k minus 4 to this, and then we multiply the k plus 5 to this, and now they all have the same lowest common denominator of k plus 5 times k minus 4, because this is already here. So what we do, so 2 times, we can just rewrite this as all over our new denominator. So 2 times k minus 4 is just 2k minus 8. Then we'll just, it's just adding by 1, so it's just positive 1, sorry. So it's just k plus 5 and then minus 9. So if we just simplify this down, this just becomes 3k minus 17 plus 5. It's just, this just becomes minus 12 over k plus 5. I'm just going to minus 4. I want to do one more with you guys real quick. We can do this one right here, because this one's very interesting. As you can see here, we don't have this middle term, but what this means is that, see, it's written in a very interesting form, where we have x squared minus a square number. We've got 4 here, so this would be 2 squared. And what this reminds me of is, it reminds me of the difference between 2 squares formula, where you have a plus b times a minus b equals a squared minus b squared. And so our a value in this circumstance would match to x, and our b value would match to 2. Just positive 2 here. So what we can do here is we can say that we have our factors x minus 2 times x plus 2, and the minus, so we can just expand, and I can just show you how these will cancel out to make our formula. So we just end up with x squared minus 2x plus 2x, and see, these terms will cancel out, and then we just have minus 2 times plus 2, which is just minus 4. And so this is just x squared minus 4, which is what we have in the numerator over here. So what we can do here is we just have, obviously we already have our plus and minus values. We can just simplify these factors down. I'll copy paste this equation so that we can work on it down here. So we have this. Alright, so now we have 4 over x plus 2. Let's just rewrite that for more convenience. Minus x, 2 minus x minus 7x over our x plus 2 x minus 2. So what we can do here is, obviously, if we can rewrite this as minus x plus 2, obviously it's just like rearranging. So what we can do here is we can multiply this middle term by a negative value, because that means we'll end up with x minus 2. And then obviously we have, it's just like in the same format as these other equations right here. So for this middle term, we'll multiply both the top and the bottom by minus 1. So we end up with minus 3 over x minus 2, and these minuses cancel out, so we end up with plus. See, now that we have x plus 2 and x minus 2, and we've got x plus 2 times x minus 2 over here, I feel like it's pretty simple as to what we have to do. We have to simplify down to this lowest common denominator. So what we'll do here is we'll multiply 4 by x minus 2, and we'll multiply 3 by x plus 2. So obviously all over x plus 2 times x minus 2, we have we have 4 times x minus 2, so 4x minus 2. It's no longer minus, remember, it's a positive because we've cancelled out this negative, so it's just plus 3x plus 6. Actually, I forgot to do something here. It's 4x minus 8 because it's minus 2 times 4, so it's just minus 8. And then we have minus 7x over here. So what this simplifies down to, obviously we have 4x plus 3x minus 7x. This is just going to be 0x or 0. And then we have minus 8 plus 6, which is just going to be minus 2. So we end up with our simplification of minus 2 over x plus 2 times x minus 2. Alright, that's just it for today's video. I hope you guys enjoyed and you understood this all. Alright, I'm going to be out now. Bye.